We are going to take kind of a turn away from just solving equations for a little bit, and we are going to move into ratios and proportions and percents for the second half of this chapter. So it's a little bit of a change from what we've been doing. But what is a ratio? What is a ratio? Jesse? All right. Say that again. Yeah, it's a number compared to another number, right? So we would say something like, what is the ratio of boys to girls in this room? So how would you find the ratio of boys to girls in this room? You'd count all the boys, and then you'd count the number of girls, and then you'd write it in a ratio. And there's 3 ways to write ratios. Does anyone know what they are? Jesse?
6 to 7.
With like the word to? Yeah, okay, so you can write it with a word. So you could say in boys to girls in this room would be 1, 2, 10 to 13. Okay, that's one way. What's another way you could write it? Jessica? 10 dot dot, which is a colon, to 13, and it's still said the same way, 10 to 13. Okay, and then there's one other way. Yep, 10 over 13. This is going to be the most common way that you'll see it, 10 over 13, because it's going to allow us to set up proportions. So for the most part, you will see it written as a fraction, but you want to be able to recognize that all 3 of these things mean the same thing. Okay, so it's not 10 out of 13, though. Why not? It's not 10 out of 13, because 10 out of 13, what would that indicate? Okay, and that would mean how many people were in the room? If it was like 10 out of 13, how many total people are in the room? 13 total people in the room, but there's actually how many people in this room? 23, right? Well, 24 including me, but I didn't count myself, right? So there's 23 people in this room, and 10 of them are boys, and 13 of them are girls. So a ratio expresses a comparison, just like Emmanuel said, between 2 numbers. What is the ratio of students to teachers in this room? 23 to 1, so we'd write that as 23 over 1. Sometimes with fractions, we say you don't need to put the 1 there, right? Do you need to in a ratio? Yes. Why? Yeah, because I matter, all right? That 1, this 1 is me, and I count, right? So that 1 is important in a ratio. You don't need it in a fraction, but you do need it in a ratio. So it should always have how many numbers? 2. There should always be 2 numbers. Can you reduce it if possible? You can. You don't have to, but you can. All right. Again, it's just as long as you remember that you need at least 2 numbers. Okay, we're out of uniform today, so this makes it a little harder. But what's the ratio of vests to long sleeve sweaters? How would you do that? Count the vests. I think there's only 1. All right, so 1 vest. And then how many long sleeve sweaters? 3. So like 1 to 3. Good. Is that different? What if I put 3 over 1? Is this correct? No. Why not? Okay, because vests is in front in the problem, which means where does vests have to go in the ratio? In the top. So the placement is really important. You can't just put it wherever you want. It's based on the order that they give you in the problem. So those are kind of like the quirky things about ratios that you need to remember. You always have to have 2 numbers, and then the order is important, okay? So what would be the ratio of girls to boys in the room? What would be the ratio of girls to boys? 13 over 10. Good. So you just flip it if it said it in a different order. Okay. The ratio of faculty members to students at a college is 1 to 15. There are actually 675 students at the school. So how many faculty members are there? So this is a very typical ratio word problem that you might see. The ratio given is 1 to 15, which means for every 1 faculty member, how many students are there? 15. But when you go to that college, is there really only 1 faculty member? No. Basically, this is the ratio reduced. So they reduced that ratio to 1 to 15, but there are actually how many students? 675. So how could you then figure out how many faculty members there are? Ray, what do you think? Okay, so you're going to want to do something where you divide 15 into 675. We're going to do this by setting up a proportion. Does anybody know what a proportion is? Or if you've heard of a proportion? Okay, a proportion is two ratios compared to each other, and they're equivalent. So we would say this ratio is 1 over 15, and that is equal to x over 675. This is a proportion because it has how many ratios in it? 2. All right, proportions can have more than 2, but we always want to work with 2 because that's going to let us solve it. Why is there an x here? Because that's our unknown. We don't know how many what there are. Faculty members. We don't know how many faculty members there are, so that's how we're going to try to figure it out. So it's really important when you set up these proportions that if students are on the bottom right here, where do students need to be in your other one? Also in the bottom. They need to be in the same spot. So if this is faculty over students, then over here you need faculty over students. So I usually just write myself a little note like that off to the side when I'm setting up the proportions. If you keep track of it in your head, that's fine. But if you're having trouble figuring out where they go, just set yourself up a little note. Faculty over students. So this must be faculty over students. All right, now how do you solve a proportion?
675 times 1,
Uh-huh.
and then divided by the denominator.
Good. What are you doing there? What is that thing called? What is that thing? Someone's saying it under their breath. What kind of multiplying? Cross multiplying. We're cross multiplying, and I've heard a lot of people call it the butterfly method. How many of you guys have seen the butterfly method? No? Oh, okay. So yeah? Okay, so some people have seen the All right, you poke cat eyes, all right? So leave it alone. Some people do the butterfly method. Okay, so the butterfly method is just a way to help you remember which ones you're multiplying. So you draw a little like butterfly around it. So you multiply 1 times 675, which is what? Okay. And then you multiply 15 times x, which is what? 15x. And then how do you finish it? You divide. That's just what Yasmin said. Okay, so you're going to end up dividing by this denominator. Divide by 15 on this side and this side. What happens to it here? It goes away. So then you have x equals, and this is going to give us 45? 45. All right. That's going to give us 45. So how many faculty members are there at that college? There's 45 faculty members. All right, which means if there's 675 students, there's 45 faculty members. And if you reduce that fraction, what would it give you? What would that fraction give you? 45 over 675 would reduce to 1 over 15. That's where the 1 over 15 came from. It's the reduced version of that fraction. So you're basically using cross multiplication to unreduce it, all right, to make it bigger, to figure out how many there actually are. Okay, so this ratio, consider that like your smallest version of the fraction, the one that's most reduced, and you're trying to kind of backwards unreduce it. All right, so how would we solve this proportion to find this missing variable? How would we find w here in this first one? What would we multiply? 9 times 3, which is 27. So 9 times 3, sometimes people just put like an x in there too. 9 times 3 is 27, and then 5 times w is 5w, so I'm going to end up dividing by 5. All right, you can leave this as a fraction, but it doesn't really make sense to do that in this case, so what I'm going to have you guys do for all of these is get calculators and actually find the decimal number. So you're going to do this, which ends up being 5.4. But you'll have a calculator, so you can just do that on your calculator. Okay, so 27 divided by 5 is 5.4. What's happening in this one? What's happening in this proportion? Just visually describe to me what's different about this one than the other ones. David? Yeah, there's more than just a plain x, right? We have an x plus 10. This is actually called a binomial, because it's got 2 terms. Bi means 2, like bicycle has 2 wheels. This is a binomial because it has 2 terms, x and 10. All right, so I put those in parentheses, which means when I multiply it, I multiply the 1 not just by the x, but also by the 10. So basically, I'm doing what with the 1? What property? Distributing. I'm distributing the 1 to everything inside the parentheses. Over here, I'm still just doing what? Multiplication. What's 8 times 12? 96. All right, what's 1 times x? 1x. And what's 1 times 10? So it would be 1x plus 10. Very good. We keep the sign right there, just like when we distribute. So just like if you were distributing it like this, you would keep that sign, 1x plus 10. Okay, now how do I solve this? First, start by doing minus 10, which gives us what? 86 equals 1x, and then how do I finish? Divide by 1, x equals 86. Okay, so when there's a binomial, what do? Distribute. Yep, when there's a binomial, distribute. And the sign should stay the same, so whatever it is. If it were minus, it would be minus over here, and then how would you cancel it out? Add it. Okay, so don't forget your algebra rules there. Do the opposites. All right. On the map, the distance from Houston to Beaumont is 0.8 inches. What is the actual distance? I have very little information in this actual problem. I have really only one piece of information. I know it's 0.8 inches. But where else is there information that I'm going to need here? Yeah, Emmanuel, where on the map? Yeah, next to the compass right here. What does this tell me? 1 inch is 100 miles, and that's written as a ratio. That's our ratio. So our ratio here is 1 inch equals 100 miles. So the top one is inches, and the bottom one is miles. Okay, so there's my ratio. But what's my actual? Equals, and where does the 0.8 go? On the top. Why? Because that's the inches, and I'm trying to figure out the miles. So I don't know that, so what do I put? X. Whatever you want. You could put M if you want, because it stands for miles. All right? So then how do I solve it? 1 times x and 100 times 0.8. So 1 times x is just 1x. What's 100 times 0.8? What is it? 80. All right. And then what am I going to do to finish? Divide by 1. Do I really need to? Not really. I know x is going to end up being 80. Good. 80 what? Miles. 80 miles. Okay, so that one is the same thing that we did, except it's not giving you all the information in a word problem. It's giving you some of the information in a picture. Why do we have scales on maps? Like, what's the point of having a scale on a map, Jessica? Yeah, because if you had a map where it showed the actual distance in miles, how big would that map be? Pretty big. Like, it would be, you'd need to unfold it all the way to Beaumont, so it wouldn't help you, right? The whole point of a map is that you're taking it and you're shrinking it down so you can actually like hold it in your hands in the car and look at it. I mean, not anymore. Now we just do it on our phones, right? But back in the day when I was taking road trips, you had an actual map. All right, and it wouldn't be helpful if your map was huge because then you wouldn't be able to see it. So this scale lets you kind of zoom in on a spot and have a smaller spot. Okay, all right, so do these 8 practice problems. I'd like you to do all of them. I think you have time. All right, so we are going to talk quickly about unit rate. Unit rate is when you're comparing two quantities that have different units. So for example, when you're comparing the ratio of 36 miles for 2 gallons. So if I have a car and it's like a, I don't know, Honda Civic. No, it's not a Harley Davidson because it's a car. So I'm driving a Honda Civic and my car gets 36 miles per 2 gallons. What does that mean? Okay. Not like opinions wise, what does that mean? But like actually, what does that mean? Right? Yeah, so if I went to the gas station and I put in 2 gallons of gas into my car, how far could I drive? 36 miles. I could only drive 36 miles, right? So 36 miles per 2 gallons of gas. It's probably more likely that this is an SUV because that's not a great gas mileage, right? So 36 miles for 2 gallons. So that's a unit, or that is a ratio of quantities with different units. That's a rate. This right here is called a rate. A unit rate specifically is a rate where you have reduced it so that it's out of what? It's out of 1. So a unit rate just means it's a rate where your second unit is reduced to 1. And if your second unit is reduced, that means your first unit also must be reduced. So if I took my Civic to the gas station and I could only get 1 gallon of gas because I only have $2.49 or whatever it costs right now, then how far could I drive? Only 18 miles, okay? So if my original rate was 36 miles per 2 gallons, that's my original rate, then all I had to do to make it a unit rate was turn the bottom one into a 1, which I do by dividing by what? 2. And if I divide by 2 on the bottom, I have to do the same thing on the top. So I have successfully converted that into a unit rate. All right? So a unit rate just means that it's over 1. Okay? It's taking whatever unit you have and turning it into a unit out of 1. The most common time that I use this, I don't know if you guys have ever noticed this, but how many of you guys ever go grocery shopping or have ever been to a grocery store? All right. And let's say you're going, and maybe you don't do this, but maybe somebody at your home does this, and you have an option between, what's a grocery store that we could pick? Walmart. Walmart has very affordable groceries, but not a store brand I can think of. Okay, so, all right. If we're not even saying which one's the best one, I just need an example. Let's go with H-E-B. Okay, because they have only because they have a store brand. All right. So let's say you go to H-E-B, and let's say you're having a birthday party, and you want to buy a lot of chips. We want to buy a lot of chips. So let's say we want to buy a lot of chips, and you go to the grocery store, and you're standing in the aisle at H-E-B, and you're like, I'm trying to pick between Lay's and the H-E-B store brand. All right? So if I go and I say, I don't have a lot of friends. Maybe you all have a lot of friends and are hosting big parties. All right? But let's say you want 6 bags of chips. Okay, so 6 bags of Lay's. All right, so let's say we're buying 6 bags of Lay's versus 6 bags of H-E-B chips. All right, so all right, let's say I want $18, or it's going to be $18 for 6 bags of Lay's, and my H-E-B brand is $15 for 6 bags. All right, right now these are rates, right? Because I'm comparing 2 different values. What's my top one? Money. My top one is dollars, and my bottom one is bags, number of bags, right? Okay, are either of these unit rates? No. Why are they not unit rates? Good. A unit rate would mean that I'm talking about the price per 1 bag of chips. So that means if I want to convert this to a unit rate, this would have to become 1 bag. So what would I do? Divide it by 6, which means up here I would divide by 6. So that gives me how much? $3. So a bag of Lay's is how much? I'm talking party size, not like the little ones. Party size bag of Lay's is about $3. Okay? Whereas over here, I still have, let's turn this one, let's say the deal was 5 bags. Let's say it was 5 bags. All right? So then what do? Divide by 5. So up here I'm going to divide by 5, and I end up with what? 3. So what did you learn about the 2 bags of chips? They both have a lot of air. They always do. It's very disappointing. They have a lot of air. But what did you notice about the H-E-B brand and the Lay's? They're really the same cost. So if you see a sign that says $18 for 6 bags of chips and $15 for 5 bags of chips, if you convert them both to unit rates, you learn that really, can you buy either one? Yes, because it's the same price per 1 bag, okay? So a unit rate is going to allow you to compare prices of the same item because you've basically, what you've done is converted it to a common unit. So instead of having 2 rates that are very different because one is for 6 bags and one is for 5, now you've converted it to a common unit so I can see I can buy either bag of chips and either way it's going to cost me the same amount. All right, so then it's really just about your taste preference. Some people like H-E-B, some people like Lay's. All right, or some people like Ruffles or whatever. Yes. But what you'll notice at the grocery store, this is my little tip for you guys, they actually do that for you. They have, you know how when you like stand in front of the Cheetos and there's like the little price tag underneath it and there's a little barcode next to it? Right above that, it gives you the unit rate. So you don't ever have to do this math because at the store it will tell you like price per ounce. So if you're ever like, should I buy the giant bag or should I buy the little bag? Because you think that the giant bag is always going to be a better deal. But if you look at the unit rate, it'll tell you sometimes it's like 50 cents per ounce versus like 82 cents per ounce. And you're like, oh, I should buy the 50 cents per ounce because that's cheaper. So they actually turn, like every grocery store everywhere puts a unit rate for every item they have. You just have to look. It's very small. All right? You're welcome. Yeah. Mm-hmm.
Do they make it small because they don't want you?
Yes. Because they're trying to trick you. They do stuff all the time where they're like, buy 10 of these for $1 each. And you see a big sign and you're like, oh, this must be cheap. I totally need 10 things of toothpaste. But if you look at the unit rate, it's like not actually cheaper to do that. They're just trying to get you to buy what they want you to buy. Everything at the grocery store is a game. Like they put everything at eye level that they want you to buy because people look at eye level. So that's why they put all like the store brand stuff is lower if you notice because they want you to spend more money.
That's why they put the milk in the back.
Yeah. So many tricks. Lots of, it's mean is what it is.
I was looking at a study. I think they were talking about how Walmart blue everywhere.
Hang on.
Should be like common.
If you're gonna talk badly about Walmart, I want to cover it. Okay. Oh, so that's why they picked blue? Yeah. Oh. Man. It works. Because man, I go into Target and can't spend less than $100.
Just a question. Would you buy one of those like medium bags? I know they have like small, medium, and large.
Like me personally?
Yeah, like would you buy one of those medium bags or like when you like at the front of the store when they have like 2 bags for 50 cents?
Oh, it depends on what it depends on what my purpose is. Usually the unit rate on like a medium bag is, if I just want a snack, I'm probably gonna buy the smaller bag. But either way, like they all have the same air in them. Like the ratio of chips to air in those bags is probably the same. So you're not really, yeah, there's more air because the bag is bigger, but.
That's why when you pop it, like.
All right, let's talk about one of these. Oh man, class went by quickly. Okay, so we do not have time to do your exit ticket. Do not worry about the exit ticket, but please stop by your boards, get your socks and markers, and put your calculators up on your way out. All right, have a great weekend, guys.